Alright class, so we're looking at lesson 1.1 which deals with extrema and average rates of change. So the first thing we want to look at is being able to analyze increasing and decreasing behavior of a graph. So when we look at that, it's an analysis of a function, can also include a description of the intervals on which the function is increasing, decreasing, or being constant. So as I look at a graph going left to right, what I'm trying to do is analyze what is happening to my y values. So when I look at this graph here, as I go in this direction, it looks during this interval that my y values are getting bigger. But when I look from this x value to this x value, it looks like it's staying constant. The y value is staying constant. And then when I look from this point all the way here, from this x value all the way to positive infinity, it looks like my graph is decreasing. So I want to be able to do this when I look at a graph. So I'm looking at this graph, f of t equals 2t squared minus 8t plus 5. So I'm looking for my graph. I'm looking from negative infinity all the way to about this point where x equals 2. It looks like it's doing something. It looks like the y values are getting smaller. So what I'm predicting is that from negative infinity to positive 2, it looks like my graph is decreasing. And then when I look from positive 2 all the way to positive infinity, it looks like my graph is increasing because my y values are getting bigger as I go to the right. So what I want to do is verify that that's the case. So the first thing I want to look at is I want to look at from negative infinity to positive 2. I want to verify that my graph is decreasing. So what I'm going to do is choose x values that go from negative infinity to positive 2, and then look at something a little bit bigger than 2. So when I plug negative 2 into my equation, I got a y value of 29. And then when I plugged 0 into my equation, I got a y value of 5. And when I went to 2, I got a y value of negative 3. Okay? When I go to positive 3, I got a y value of negative 1. So it looks like when I look at my graph that as the x values are getting bigger to positive 2, my graph is decreasing because the y values are decreasing. I can't go to 3 because when I go from 2 to 3, it looks like the y value is getting bigger. So what I'm doing is choosing 4 points, 3 that are before it, 1 that's after it, after the x value, and I'm using those points to verify that my graph is increasing or decreasing. In this case, from negative infinity to positive 2, it's decreasing. So what I want to do next is look at this other part, this last part, from positive 2 on, what is my graph doing? So I plugged in values, one before that, which was 1, and then I plugged in 2, 3, and 4. So when I went from 1, I got negative 1, and when I plugged 2 in, I got negative 3. So it looks like it's decreasing between those values, but then when I go to positive 3, which is like the next integer after 2, it's increasing. The y value is getting bigger. And when I plugged 4 in, I also got it to be increasing. So this verifies that from 2 to positive infinity, my graph is increasing. So all I'm going to say is for this graph, from 2 to 0, it's increasing. From negative infinity to 2, my graph is decreasing. So let's look at another example. So in this graph, I have a piecewise function. This first part from that x values are less than negative 3.1. It looks like my equation is 3x plus 11, and then the other one is y equals 1.7. So what I want to do is, as I look for my graph left to right up until negative 3.1, what is my graph doing? So what are happening to my y values? So as I start from negative infinity all the way to negative 3.1, it looks like my graph is increasing. And then when I look at all the way from negative 3.1 to the end of my graph, because this keeps going on and on and on this way, all the way to positive infinity, my graph looks like it's staying constant. My y values are staying constant the whole time. So let's plug in some values and see what happens. So when I plug in a value that's further to the left than negative 3.1, like if I plug in negative 5 and negative 4, my y values are getting bigger. And then when I plug in negative 3.1, I get 1.7. So it does look like my y values are getting bigger. When I plug a value with an integer after negative 3.1, which is negative 2 in this case, I got 1.7. So this verifies that in my graph from negative infinity all the way to negative 3.1, my graph is increasing. So all you have to do is plug in 3 or 4 values into your equation just to show that my y values are increasing, which I do show right here. And then I want to plug in one value after it to show that that's not increasing as well. So let's look at the next one. So in this case, I just plugged in values from negative 3.1. I plugged in negative 4, which was the integer before it, and went all the way to negative 2 and 0. From negative 1 to 1.7, it looks like it's increasing, but then from negative 3.1 all the way to 0, it has the same y values. So I can say from negative 3.1 to infinity, my graph is constant. So I know it's constant from negative 3.1 to infinity, and then I know from negative infinity to negative 3.1, my graph was increasing. So what I want to do you guys to do for our next class is to be able to look at this one, and we'll go over this in class. Thanks for listening.